Thank you very much to the Kaspersky organization for inviting me for this conference. I have two challenges in this presentation. One, of course, this is the last presentation, and I have to justify that all this audience waited for me. Second, to speak after Marina, it's another challenge, and it happened to be second time. So we are ready to go. We are going to talk about designing cybersecurity building management systems. This presentation is a result of my work in a team for cybersecuring a brand new government building in Israel. I am part of the cybersecurity team, and our role is to supervise what is happening and making sure that all contractors know that this project is going to be unique and the result should be a cybersecurity project. We all know that the BMS belongs to the family of ICS, Industrial Control Systems, and rule number one is always, if you want to deal with cybersecurity of industrial control systems, you must understand the architecture of the project, the application, the process, the flow of the information. You must understand what can be done, what cannot be done specifically for securing the system. So this is basically the introduction to the presentation. As I said, BMS belongs to ICS, and the unique characteristics of this specific application, and this is already reflecting the project that we are doing, that the control is divided to three parts. Why it is so important? Because there are three unique parts, and each of them must be handled from cybersecurity and also from ICS process separately. At the end of the day, everything must go to the control room, and there will be a SOC and analysts who need to understand. And our role is to make sure that the person who is sitting next to the SOC screen, he does not have to be an ICS expert. Why? Because the information should be processed in a way that he does not have to be an ICS expert. Then he needs to see that something is happening. He needs to understand the severity of the event and act accordingly. So the three parts that we are talking about, let's go from the top to down. The offices, which are above the ground, and I just listed all the types of systems which are being controlled: the elevator, the fire and smoke, the access control, various cameras, of course, the HVAC, the heat and air conditioning system. Everything must be controlled, monitored, and make sure that it's in healthy condition and it's operating exactly as expected. The second area, also from cybersecurity aspects, is everything which is outside. Why I say the word outside? Because naturally what is installed outside, it can be electrical power grid, it can be fuel tanks for the generator. These systems are less protected because they are outside of the building. Whatever is inside the building, there is physical security, there are guards, and everything is much better. So external installations should be handled separately. Then we have the underground facilities, and the work that I'm doing, our team is doing. We are specifically dealing with the underground facilities, where are all the utilities, the chillers, the generators, the UPS, the cracks, the data center, and of course, everywhere we have CCTV cameras. We don't need to mention, but all the underground facilities. So all these three zones must be separately handled as an industrial control system and separately handled from cybersecurity according to the risk and according to what can be done and what cannot be done, and what should be done according to the budget which the customer is allocating to us. When we speak about wide range of incidents, when we deal with cybersecurity risk, we always ask what can happen, and then I listed here. By the way, whoever is interested in this presentation, I will be happy to distribute it in addition what is available. So we deal with energy control related attacks, something that might affect the supply of energy, operator-related attacks, wide range of topics which need to be addressed. Also, IT-related attacks. When we speak about IT-related attacks in the ICS, this must be explained. Because if somebody is stealing information from the ICS, it's not because there are some credit cards or values, because in this information, he can reuse the information to create a larger attack. So what attacker can do, he can steal information, IP addresses, type of PLCs, whatever information he can get in order to prepare a larger attack. And this is also a problem. Then we need to talk about the security and safety-related attack, everything what is. So we are not talking about electricity, but security and safety of people. This is very important. And then, of course, interruption of the service, and the data center and the computer room air conditioning are part of this activity. So you can see here a wide range of topics that we need to deal with them with each and every one and separately. When we speak about the attack on the industrial control system, so we are separately looking at what can be done internally. Internally generated attack means the attacker is penetrating to the facility, not easy because the facility should be protected, and externally generated cyber attack. Externally generated is, of course, compromising through the communication, through the internet network, the IT section, and so on. And finally, the attacker can penetrate to the system. I provided a list of a type of people and type of attackers who can be interested or may be capable of doing it. So this is what we need to take into consideration. And when we handle risk management, we are looking into these topics. Furthermore, we are looking at the supply chain type attack. We all know that when such a building is being constructed, you have suppliers, you have service providers, you have computer, PLC, communication, wide range of suppliers. And we need to define to each and every supplier. So what we did, we received a very complex specification written by the customer. Here is how cybersecurity should look, but can you deliver this piece of material to the electricity guy or the air conditioning guy? He even will not know how to read this material. So we had to translate, not physically translate, but convert that specific information to each and every profession, and in their simple words, explain them how they need to design and implement their system in order to comply with cyber security risks. Making sure, for example, a very simple rule, you will never bring your service computer into our facility. You will always use our computer. You will get the computer, do the work, return to us the computer. You never leave a backdoor, and all kind of list of guidelines, which some of them are objecting, said, why you are telling? We never received such requirements. Very good. From now on, you can come. We will give you your computer, you do the work, and so on. You never leave a backdoor, you never connect remotely because you are unable to connect remotely. Okay, to that system, and whatever service will need to be provided, it will be done properly. Furthermore, we in order to deal with this project, we had to divide this whole system into zones, okay? And for each and every profession, for each and every contractor, for each and every designer, we had to give them the guideline what they can do, what they cannot do. Specifically, our job was specifically focusing on the underground section where you have the utilities and wide range of installations. Once we did it, and we are not waiting until the project is completed. We are constantly doing assessment, risk assessment. When we receive a design, we receive the blueprint, we receive the description, and say, okay, let's do now risk assessment. What can be done? What can be done if you purchase or how it can be detected? You purchase a PLC which already have the malware inside. How we are going to detect a computer which already have the malware inside? How we are going to deal with the communication? So we are inspecting each and every segment of this project during the time when the contractors are designing, and we are not shy to say, sorry, take your drawings back, you need to rewrite it, you need to redesign it. We will not allow you to have TCP communication to a lousy controller which is built into one of the machines. You will need to have some kind of very simple serial communication. We will not allow you to use protocol converted. Each protocol conversion will be done by a PLC. Why? Because the PLC by itself can do some type of verification. He is receiving information, double temperature. The PLC may run some process, say, no, I'm not going to double the temperature, because according to my rule, you can increase the temperature by 5% every half an hour. This is my rule, and I cannot. So we are filtering each and every piece of information. Then we are looking at what can happen. Of course, we are always looking at the risk, which is the probability and the impact of what can happen to the system. And this is the way how we are guiding the process of engineering deployment. It didn't start yet, but will start soon. We are guiding the selection of the contractor. We need to hire a cyber contractor, what type of ideas he's going to deploy, who is going to deploy it, what kind of capability these people have, and then we are going to decide who is going to be the winner. Of course, this is a regular tender process. Furthermore, when we are looking how to, because what is our role? Our role is not cybersecurity. Our role is assuring of business continuity of that building. Okay, this is the role. In the morning, it was already said a couple of times, don't deal with security, you assure business continuity, make sure that the entire system is working properly. So what we are doing for each and every section in the network which is being controlled, we will have a main control area and we will have a verification area. What does it mean, verification area? For example, let's say that you have let's call it a chiller producing the cold air. So you have a built-in controller which is reporting to you how this piece of machine working. We say, well, it's interesting, but how about this controller is already compromised? So we are going to deploy a set of separate independent sensors which have their own control logic, and we are going to compare. The crack is reporting about this and this and this. These independent sensors are reporting a different temperature. What is going on? Something is wrong. We all know that once you detect the problem, this is half of the solution. So we will have on the left side, you will see a control part. On the right side, you will see a separate set of activities for verification. They are all connected together. I don't want you to be scared. Here I'm showing that they are connected to a switch, but in reality it's more complicated. There are isolated sections through an air gap, so it's not so simple as it's shown here, but I wanted to show a simple solution. Each and every device which is connecting to the main building network is being tested, okay? test by authentication. Is this controller or this PLC allowed to be connected? 802.1x is one of the processes. We have some other processes which will allow, but this will help us to detect if suddenly a strange device is connecting. We will immediately detect, we will immediately report. The report will go to will be recorded by the ITS. It will go to the SIM. From the SIM, it will go to the socket. In the control room, somebody will receive immediately an alert that something is connected. So this is one of the areas what we call verification. We are going strongly to rely on redundancy. We all know that there are more critical parts in this system and less critical parts. So for the more critical parts of the system, we will have verification. How it can be done? You can take a PLC and use two analog inputs or digital inputs connected to the sensor. You can take two PLCs which are monitoring two different sensors. All the possibilities according to what makes sense, but definitely we are going to deploy redundancy in the control, and for very critical parts of the system, also redundancy on the verification. So see how this machine, how we are thinking. Business continuity. It should be a cyber-secured system to assure business continuity. This is the whole idea, and we are investing efforts and design capabilities into this area. There will be redundant servers. There will be full redundancy will be deployed in every part of such a system. If I want to look at the complete diagram, again, obviously the system is more complicated. I don't show here the air gapping, the isolation between the zones, but at the beginning of my talk, I mentioned that there are three areas: at the upper the layers above the ground, the offices, everything what is outside of the building, which is handled separately. Some parts may be very critical, some parts may be less critical, and of course the underground installations, which are also being monitored. Each of these installations will have a main control system. The main control system will have two switches, will have two servers, will have redundancy for the operation, and on the top, we will have what we call verification. Verification, as I mentioned, independently, I'm going to assign set of sensors to verify that what I'm receiving, that the information which is being generated by the main control system makes sense. It makes sense, or there is a discrepancy between these reports, and then furthermore, the entire system is designed for manual operation of the critical functions. So if we realize that something very bad happens and the whole system is out of control, then we will have an arrangement to handle manual activation of the electric supply, UPSs, air conditioning, the crack for the data server at all. So this is all built in. Furthermore, on the right side, you see a diode which is illustrating, there will be actually more diodes in the real system, which is illustrating the data is being exported to the SIM. Why we are using a diode? Because we don't want to have too many SIMs, and so one SIM will be doing several functions, and we want to make sure that we are not creating any connection between the isolated zones. So the information will go to the SIM, which will analyze the information and prepare that information to be submitted to the control room. On the left side, you see some colors which shows you which is the main system and the backup system and so on. Here I show another diagram which is showing that the information coming to the SIM from various areas in the system through the diode, and then it will go to the SOC for the BMS center. So we assure that the architecture will be cyber secured properly. This is very important, and through this activity, we of course assure the business continuity. Furthermore, what we are, just to summarize it, I show here a couple of the summary of details, how this entire process is being connected. All the information, everything is coming to the control room. We are not forgetting a situation that the control room may be in some kind of trouble, fire or any problem, and somebody will have to evacuate the control room and run the control from a different building. So we will have, it's not shown here, but we will have a separate arrangement which is allowing through some type of KVM connection to allocate a remote control room in order to perform all these critical functions, make sure that the building is properly supervised. Furthermore, when we are talking about building an energy management system, we know very well that there is a great deal of expertise which is required. Expertise in the area of industrial control systems, specifically for building management system. Expertise in the area of cybersecurity, what you can do, what you cannot do, and how you are going to analyze the data which is produced by so many control systems and several verification systems, how you are going to analyze all this data. So definitely this is not part of this project, but there are solutions for a service provider, for security service providers, which can run this process for the company, for the organization, and of course return the information. This managed security service provider can be a permanent solution, or can be a redundant solution. Something goes wrong, for whatever reason you are not trusting your system, you can export the data to the managed security service provider. There will be a separate operation there, and the information with the alert will come back to the control room or any type of security room which is assigned. So what we are seeing here, a complete thinking about how to handle a cyber-secured building management system with the goal to assure business continuity. This is the goal, because if something will happen, if you have a smoke alarm, a fake smoke alarm, because of that you need to evacuate the building, or for some reason their conditioning is not working. Of course, you will have a UPS for a short period of time. It will handle you for maybe half an hour, but eventually you will have to evacuate the building, and if you have many employees in this building, this is a problem. So this whole concept of how we handle that project was completely defined by the customer. We are implementing that requirement and managing the contractors. Finally, I would like to summarize. I'm not going to talk about the famous PPT, the people, policies, technologies, which is always applicable for all type of systems. I didn't mention here the other triad, which is applicable for manufacturing and critical machinery, which is safety, reliability, and productivity. But I do want to mention here another triad, which we call RDC, redundancy, diversity and complexity. Redundancy means that you don't want to rely on any specific part in the system which may disturb the operation. You want to be sure if it's sensor, it's critical, there must be a redundant. If it's the server, if it's the switch, if it's the IDS, anything that you feel that you need redundancy, you can add it there. Diversity is a tricky recommendation because on one hand we like to say, let's do standardization. Let's use one type of firewall, one type of switch because it will be convenient for the maintenance. But here, from cybersecurity concept, we say diversity. Why don't you use different firewalls? Use from vendor A or vendor B. Why? Because the attack, you will make it more difficult for the attacker. He not only will have to study how to compromise one firewall, now we have to learn another firewall how to compromise it and do it in the same way, so diversity. The third one is always a tricky recommendation because we like, specifically industrial control systems, we like to say, keep it simple. The simple systems are always working. But suddenly here, we say complexity. Make it a little bit more complicated. Make it less clear. So if somebody will penetrate to your system and try to identify what is going on, it will be more difficult for him to learn the system because suddenly he sees here complex solutions which he may never seen before, and we are going to implement it as well. Finally, in order to summarize this presentation, I always stick to this couple of slogans which always say, define the main goals, deal with vendors who take cybersecurity seriously. Because, you can always find the lowest cost. For example, when we define the PLC, we say it must be a PLC from a leading vendor who is strongly represented in the country, who have a service center with experts in the country, who is keeping spare parts in the country. Otherwise, don't bring me this PLC. HMI, IT components in the system, everything should be done. Do not compromise on requirement. I say don't give up if somebody is convincing you. And finally, always be ready for challenges and expect the unexpected. This is the message that we wake up in the morning and go sleep every day. What will happen tomorrow? It's another day, and we need to be ready. So thank you very much for your patience. Thank you for participating in this presentation. The presentation can be available, whoever wants to receive it, or if it will be published by Kaspersky. Most important is, let's make the world a cyber-secured place by good solutions, educations, and do best whatever we can do. Let's do it the best. Thank you very much. This is my last presentation.